Welcome back to the third and final chapter. Let's check in on where we are in the data analysis process. So far, we have spent a lot of time exploring, cleaning, and preparing our Kickstarter data. Now we're going to do some analysis so we can better understand what makes a good Kickstarter project. This lesson will focus on counting. When doing analysis, it's important to understand how many records or values you have, and even look at how many blank cells you have can be informative. In Excel terms, count refers to the number of cells. However, there are a few variations of the count function that count based on different criteria. Let's take a closer look at each of these. Let's start with the basic count function. The function counts the number of cells that contain numbers in a given range. So pay attention to the data types in the cell range of interest. Count only counts numeric values. Here you can see the syntax as an example. The count_a function counts the number of cells that are not empty in a range regardless of the type of data it contains. The syntax is very similar to that of count. Here you can see an example. Lastly, there is count_blank. As the name implies, it counts the number of blank or empty cells. Here you can see the syntax and an example. A few special notes on count_blank. Cells with formulas that return double quotes twice, an empty text, are counted. Cells with 0 values are not counted. Let's apply all these functions to the same data range, namely the first 10 records of the goal and city fields. Does anything look wrong with the results? That's right, the count_blank function hasn't captured all the supposedly blank cells. You should be mindful that sometimes people enter a space when inputting data into a database instead of leaving a field blank. When you discover this, you can take a step back from analyzing the data and go back into cleaning mode. As we covered in Chapter 1, you can use the trim function to ensure blank-looking cells are actually blank. In the real world, the data analysis process is not strictly linear. You often have to go back to clean or prep the data, or even go back further to refine the business question. Let's start counting. In this video, we'll discuss a number of aggregation functions that will help you summarize your data. You can certainly use Excel to do simple math like 2 plus 2. But now imagine you have a large number of cells to add. Wouldn't it be nice to be able to use a function? Luckily, Excel has a large number of math functions for us to use to choose from to make analysis easier. Why is it important to know how to do aggregate or math functions? Because it's a great way to make your analysis easier and to get a good understanding of your dataset. All the aggregation functions in this lesson have a similar syntax. Start with the function name, then provide the data range you want to calculate. Let's focus on the goal data for our analysis. Starting with addition, there's the sum function. Here's the syntax and an example. Note that any cells that contain text or dates in the data range won't affect the function. Excel skips over those cells in the range when calculating the sum. In colloquial English, people often interchange the terms sum and count. You need to be mindful that the sum function adds the values in the selected range, whereas the count function counts the number of cells that contain a numeric value. Next, we're going to take the functions to the max. Well, to the max and min, actually. These functions often go hand in hand. Here you can see the syntax and an example. Max returns the largest value in the range, and min returns the smallest. Special note, if the range doesn't contain any numbers, both of these functions will return 0. Another common function is average. In school, you may have had to manually calculate the average or mean of a group of numbers. To do that, you had to add up all the values and then divide that sum by the count of values. In Excel, all you have to do is provide the range of cells you want to use, and it does all the calculating for you. Note that if you have blank cells in the range, they will not be included in the calculation. The last basic aggregation is median, the middle number of a group of numbers listed smallest to largest. Half the numbers have values that are greater than the median, and half the numbers have values that are less than the median. On the slide, you can see the syntax and an example. Maybe you've heard of median in demographic reports. Oftentimes, it's used as a point of comparison to average. For example, the 2018 median income per capita was $33,706. The mean income per capita was $50,431. Mean, or average, together with median, can help you understand the distribution of values. The closer these numbers are, the more evenly distributed the values are. If they are very far apart, the data set is likely skewed. Descriptive statistics is outside the scope of this course, but check out the linked article for more information. Let's get calculating. As we covered earlier, logic values are either true or false. In this video, we'll cover logic functions. These functions allow us to ask complex questions of our data. They analyze information and determine whether a certain set of criteria is met, returning either true or false. You probably don't realize how often you use this kind of logic all the time. For example, if your hand gets too close to a fire, then you move it away. If you don't, you might get hurt. Or if it's raining outside, you will use an umbrella on your walk. If you don't, you will get wet. In data analysis, you can ask Excel to make similar true-false determinations. For example, you can use a logical function to identify all the rows in which a project had more than 50 backers, or if a project is from the United Kingdom. So how do we do this in Excel? We use the if function. There are a few arguments in this function. The first argument is the criteria you want to test. The second argument is the value you want to return if the result of the test is true. The last argument is the value that needs to be returned if the result of the test is false. Let's look at a simple example. If the USD pledged amount, which can be found in cell I2, is greater than the goal amount, which can be found in cell J2, then we label the project a successful project. If the condition is not met, we assign the label failed project. Now let's make it a little more complicated. We are going to test the same criteria, but if the test proves true, we will show the dollar amount by which the pledge amount surpassed the goal. If the USD pledged is not higher than the goal amount, we'll show how much it fell short. As you can see, you can return text or calculations. Besides if, there are two other important functions, and or. Here you can see the syntax of the AND function. It can test multiple criteria at the same time. AND returns true if all the arguments evaluate to true, and false if one or more of the arguments evaluate to false. OR has a similar syntax, but now true is returned if any of the arguments evaluate to true, and false if all the arguments evaluate to false. If you want to test multiple criteria, it's common to use AND or functions nested within the arguments of the if function. When you need all the criteria to be true, use the AND function. When you need only one of the criteria to be true, use the OR function. Let's take a look at how the nested if formula works with AND using our dataset. We want to test if a project is from the United Kingdom and raised more than $1,000. You start with if, and for the first argument, you will insert the AND function with both criteria you want to test. If both criteria are true, a value of yes is returned. If one or none of the criteria is true, the value no is returned. Your turn to start thinking logically. Now that you've mastered the if function, you might be asking how to combine some of the aggregation functions like count, sum, average with if. This way you can start doing analysis on the field level, not just cell by cell. Let's take a look. Let's calculate how many projects there are by country. To get started, we will need to create a table that lists all the countries in the dataset so we have some place to put the calculation. As you can probably guess, there's a useful function for that called unique. On the side you can see the syntax and an example. This returns a list of all the unique values or names in the selected range. We can create our list of countries by selecting the country column as the data range. The unique function returns results in the order in which they are located in the array. Let's make the result look nicer by sorting it alphabetically. Do you remember what function we can wrap around the formula to do this? Yep, sort. Now that we have the destination table, let's add in the project count by country. To do this, we have to use the countif function. The countif function syntax requires the data range to count, then the criteria. In this example, we are using the country names as our criteria. This means that in cell T2, we are counting the number of cells in the country column, column M, that satisfies the condition that the country name is equal to in cell S2, Austria in this case. Note we have used the reference M:M to look at the entire column of data. Since we are restricting the results based on the specific country name, we don't have to restrict the range to just the specific range, as we have done in past lessons. What happens if we want the range that we test our criteria on to be different than the range of the calculation? For example, if we want to calculate the pledged average or sum by country, we can do this by adding the average if or sum if functions to our destination table. The syntax for both of these functions is similar. The first argument is the lookup range you want to test, in this case, the country column M. The next argument lists the criteria. Here, that is the specific country name from the destination table. For the second row, this is S2 or Austria. The third and last argument is the range on which we will calculate the sum and average, in this case, the USD pledged column I. Now, what happens if we have more than one criteria to consider? Let's figure out what the average pledged amount is by country, but only for successful projects. The function is average ifs. Note the s added to the end of the function name. That tells Excel you may have more than one criteria to test, but you can use this function when you have only one criteria to consider. Then, the function will work the same as average if. In terms of syntax, average ifs start with the calculation range, then the first criteria range, then the first criteria. To add another criteria, just repeat the pattern of range and criteria. Let's look at an example. The calculation range is the USD pledged data, which is in column I. The first criteria range is the country in column M. The first criteria checks for the country name. The second criteria range is the status column P, and is followed by the test. To write a specific text test, use double quotes around the text you want to match. Excel is not case sensitive in this situation. Take note of the errors included. These appear because there is no successful projects in those countries. We have a summary table of valuable analysis in our dataset. Now you give it a try. Well done. Let's review what you've learned throughout the course. In Chapter 1, we discussed the data analysis process and started applying it by forming the business question, getting the dataset into Excel, and exploring the fields included in the Kickstarter dataset. In Chapter 2, we focused on cleaning the data. We covered a variety of functions to prepare text and date fields. Additionally, we learned how to add data into our dataset from another table with VLOOKUP. In Chapter 3, we got down to business and used an assortment of functions to analyze the Kickstarter data and better understand what features successful projects have in common. Look at all the many functions we covered throughout the course. This represents just a small portion of what Excel has to offer. Thank you for all the time you have dedicated to this course. It has been my pleasure working with you. I hope you now feel ready working with your own data in Excel. Good luck.